Howdy folks. So I recently went out and purchased a new tool, and I call this a tool rather than a toy because I think this is really a useful tool if you know how to use it. This is a Seek thermal imaging camera, and this is just an Android attached device. This is pretty much the cheapest thermal camera on the market as of now, and has been for about a year now. So, of course, I've taken it out of the packaging, but this is what you get. It's just a magnetic box. And they do make an iPhone version of this, but, well, I mean, it's pretty much the same thing, except it's got a lightning connector on it. And it's for the Apple fanboys. So, anyway, the box is kind of useless. The device comes in a little case, which is actually quite nice. Some people complain this is a little bit big, but I like it. It's got a little, you can clip it onto things. It's hard. It's got a very strong snap on it, clear lid, and it's got a nice rubberized inside that grips the device. So I really like this. I mean, it's a really nice case. And then you've got the actual camera itself. And the first thing that you will notice is it is incredibly small. If you watch any videos on YouTube about this, which you undoubtedly will, you probably, you see this in the video, on your monitor, and it looks so big, and I've even heard other YouTubers say it's small, but I mean, until you get it, you really don't realize the scale of this thing. Now, one thing that really surprised me when I bought mine was I didn't notice that it had this rubberized ring on the lens, because all of the videos that I watch were people who bought them very early on, usually like end of 2014, early 2015. And they all had fixed lenses, and they only focused up to about a foot. And if you wanted to look at anything closer than that, you had to buy a zinc selenide lens off of eBay or something, and then basically glue it on the front, and that way you could get macro. But this one actually has a turnable lens on it, and you can focus up to about an inch with the provided lens. And this really amazed me. I mean, this is a really great feature. I actually already bought a lens for this. I bought this, and then I bought a lens from China, because the lead time, so I wanted to sort of give it a head start. So I actually ended up buying a lens that I don't need, and when it comes in, I'm not sure what I'm going to do with it. But I did not know that they made this change, so that's one of the reasons why I'm making this video, is just because, I haven't seen any new reviews or unboxings of this, so I don't know if people know that they actually get an adjustable lens on the new cameras. It's a really big deal for me, because 90% of the stuff I do is going to be macro. So the case is a magnesium, obviously for thermal, and we've just got the USB micro right there. So let me just get my my phone. Now, this is my old phone. This is my Samsung Galaxy S4, and this is pretty much a dedicated thermal camera phone now. It doesn't have service anymore, so it's just always in airplane mode. And this thing is just powerful enough to do this okay-ish. And the reason why I say that is this thing requires a lot of processing power for high frame rates. And when I say high frame rates, I mean we're talking like 8 or 9 FPS. There's an export restriction, I think, in the US that limits the frame rate you can actually have on a thermal camera, because I think it's like something that they don't want them in heat-seeking missiles or something stupid like that, some military thing. Just like how GPS, you can't have them fly at a certain height and a certain speed because it thinks it's in a ballistic missile. Same thing. But if you run it on this phone, which gets an Antutu benchmark of about 25,000 or so, it lags and it frame drops a lot. If you run it on a newer phone, in particular, I have the LG G4. This is my primary phone. This has an Antutu benchmark of about 50,000, so about double the processing power of this. And this, it performs extremely well. Obviously, what it's designed to perform like. So this is sort of on the lower end of the compatibility scale, but it will still work. So that's one of the big things you got to sort of realize with this is the performance you get out of the camera is going to relate to the performance of the phone that you couple it with. So, I mean, if you have a really low-end phone that's just inside the compatibility for this, you may want to just be wary of that, I guess. So I'll show you what it looks like on this phone, just because. I have a bunch of sample videos and sample stills and stuff, which I will inset. You can set it up so that Android will automatically open the app, but you have to always give it permission every time it starts. And you'll hear that what it's doing is it has a shutter in it, which is used for non-uniformity correction to make sure that it basically puts a shutter in front of the lens so that all it sees is just a blank shutter, which is all the same temperature, and it can then calibrate the microbolometer inside so that everything is uniform, and that way it reduces noise. And basically, it's very, very complicated how it actually works, but the app works in all orientations, and it transitions in a relatively nice way. It also works upside down, which is excellent because, of course, when you have it the normal way, it's kind of strange to hold your phone like this so that you're not blocking the lens. But by holding it upside down, it actually works out quite well. So I'm quite happy that you can rotate it 180 degrees. So it's difficult for me to get this all in shot because unfortunately there's not much that I can show you that's a different temperature. But you can see here the kind of lag that I'm talking about when it changes a lot. And has to do a new gradient, you can see how laggy it can get. So it seems that how many pixels change on the screen at a time, like in a drastic way, seems to affect the amount of processing power that this thing requires. You can see I can get a lot more responsiveness out of it. There's just a metal pole here for my other tripod that you can see. So you get a lot more responsiveness when the scene doesn't have as much of a thermal gradient. You can basically take still photos. You can take videos. You can do spot mode, which just tells you what it thinks the temperature of the center of the screen is. You can have the min and max, and you can set it such that only above or below certain values will be colorized, and that's pretty much it. Now you can change the color palette. Pretty much grayscale is pretty much what it sees, and of course it just colorizes everything according to thresholds. So grayscale pretty much makes the most sense for accuracy. And I don't know if the lens is focused or not right now. I'm not entirely sure. I don't think the lens is focused right now. It's unfortunately difficult to do. When I first got it, I didn't know that the lens was adjustable, so I actually took some photographs and I was absolutely appalled at how bad the quality was, and only did I eventually realize that it was pre-focused in sort of a macro mode, and I was trying to take distance shots, and so once I finally got the focus right, it's actually a lot sharper than you might think for something that is really effectively 200 by 150 pixels. The other thing with it is it's difficult to focus because the lag. You know, you turn the knob and you don't really get to see what you've done until you've gone too far and you overshoot. So it takes a little bit of getting used to get it focused right. But the app really doesn't have very many features. It allows you to do basically between the visible camera and the thermal camera, but it's pretty much useless on 99% of the phones that I've seen this used on, simply because of the the parallax between the camera sensor, because of course one of them is here and the other one is here, so that distance plus the focal length and the field of view, and it's all different, so really it doesn't work very well. I have a video coming up where I hack this, and I'll show you some cool stuff that I'm gonna do with a laptop and stuff, but that's a future video. I'm just working on that right now. So really that's really all you've got here. Not a big deal. And just for comparison, I will put it on my other phone just so that you can see the difference. Just get that out here. Now you can hear it activates the shutter a lot more often when it starts up, and then it goes down to a much slower, more reasonable time after that. Now I believe I have rotation turned off, yes. So if I turn rotation on, then I can go upside down. So you can see now the it's quite a bit more responsive with this phone than with the other phone. So clearly the amount of processing power the phone has does affect the performance of the camera. Now that being said, this will destroy the batteries in your phone. This itself really doesn't use that much power. If I remember correctly, Mike's Electric Stuff measured the power consumption of this as about 90 milliamps or so, which is really not that bad. But the processing power that the image processing uses will drain your battery like no tomorrow. This phone pretty much drops about 1 to 2 minutes per percent. I should have worded it later. So basically it drops about 1% per minute to 1% every 2 minutes with this doing active imaging. It really is kind of ridiculous. The S4 is about the same. That's why I really use this as, like, even though it's slower, I like this as a dedicated thermal imaging phone, because A, I can use this while this is being used as a camera, but also this, the battery can go flat and I don't really care, but of course this, the battery can't go flat, it's my phone, I need it. So that's why I've got a secondary device for this, and I'll just sort of suffer through the lower frame rate. I've recorded videos on this, and it doesn't seem to be that bad. I mean, the video frame rate is the same as what you see if you're not taking video. So whatever video encoding they do must not really have that much of an overhead. So it doesn't really affect it that much. So when I do my next video, I'll probably put some more clips in. Actually, I'll put some clips at the end of this video. I'll put some clips at the end of this video and a couple photographs of some equipment and some use cases for this product. I'll just sort of overdub some images with some audio and just sort of go over things. But anyway, hopefully this was somewhat helpful. The only really new information I'm bringing was really the fact that it has an adjustable lens on it. But I mean, I'm going to be doing a lot of work with this. Probably quite a few videos with this over the next little bit, simply because I mean it's a very cool thing, and it's I mean, Seek, they've got their slogan here, "See the unseen." I mean, I'm not sponsored by Seek, but I think that is actually, I mean, it's really quite an amazing ability to see thermal energy. It allows you to do so much stuff you could never think was possible. And there's a lot of really clever uses that maybe most people don't think about. So I'm going to do a couple videos with this, but this is just the first one showing basically what it does to the average Joe. But I'm going to connect this to PCs. I'm going to do some image processing stuff with some special Linux drivers that have been reverse engineered for it, and a bunch of other hacking type stuff with it. So look forward to seeing those videos. So this is the first image I actually took with the camera as soon as I got it out of the box. And as you can see, it's extremely blurry. The thing that's bright yellow in the top right is actually a lamp, a floor lamp. So yeah, you definitely couldn't really use the camera in that state. So they really should indicate that it's a adjustable focus. This is an image of inside of my desktop workstation. So this is a computer. So you can see the loop on the top is actually a liquid cooling loop. So that's why that's cooler than the rest. We have an audio card and a graphics card and some network cards, which all, of course, have hot spots on them. You can actually see in the top left there's actually an exhaust fan, and you can actually see the heat from the motor in the middle there. We also have, this is just a photograph of some of my networking gear, which I looked at in a previous video, which I'll link in below. And this, we have just a PC, which is a server. We've got a switch, a wireless router, and a modem. And you can see the hot spots where the processors are in each one. So you can see, for example, that switch. There's more heat on one side than the other. Now, that could be heat from the switch. It could just be that the processor that's mostly getting used is on that side. Now I know for a fact that actually the power supply is under there, so that's why that's hotter than everything else. Just a close up so you can see if you open this, there's actually the system on a chip is actually right under that hot area there, so you can see sort of where things are through plastics and stuff. You can see how the heat is rising up through this modem and pooling at the top. This is a close-up of my liquid cooling pump for that PC I showed you earlier, and you can see the thermal profile of that. It's very hot on one side in particular, which is most likely where the speed controller is. This is a macro shot that I took by adjusting the lens. The object in the middle that's hot there is a D-pack, surface mount D-pack, and the cool object in the on the top right there is actually a 32 kilohertz watch crystal. This is actually a motherboard, and that connector down in the lower right is a fan connector. This is just a standard USB power supply. This is actually one of the cylindrical ones by Hewlett-Packard for the WebOS tablets. I never owned one of the tablets, but I did have one of the power supplies. So there's just a USB lead clipped in there. So this is an interesting shot. This is of a BenQ DLP multimedia projector in my theater, and this projector is off and has been off for pretty much 24 hours. So you can see it's clearly much warmer than the surrounding environment. So even though this projector is off, it's using up quite a substantial amount of power just to, for it to be that temperature. So that's one interesting use of a thermal camera, is you can see electronics that are using power even when they're off, and how much relative power, because of course most of that energy they use is turned into heat, so you can see that. This is the exact same projector after running for about an hour or so. So you can see clearly the exhaust vent is on the lower right there. So that's obviously where most of the heat is, and the bulb is obviously near the front there. And this is the front angle. So you can see the BenQ logo in the front there. Again, this is a receiver, same thing, home theater. This is after being on for an hour or so. So you can see right down the middle there, that line of hot. That is actually where the main heatsink is for the power devices inside. You can also find bad electrical connections with a thermal camera because, of course, bad electrical connections will get hot inherently. And this is a connection to my Variac after it was running a 60 watt load or so for about half an hour. I just sort of scanned around, and one of the 4 terminal lugs on the front looked like this, whereas all the rest were pretty much invisible. They were all the same temperature. So as it turns out, this lug had actually come loose. So you can find intermittent electrical faults with a thermal camera quite easily if you know what to look for. You can also use it to look at lighting, things like LED lights to see how hot they're getting. In this case, this is actually just a CFL pot light, but the same thing, you can see how hot they're getting, and this is where you can use the min and max feature. Now, this is kind of unusual. When I took this photograph, the dot, the 93 degree point, was directly in the center of the light. However, when I took the image, it's shifted it up and to the left a bit, and I can't quite explain that. And it did the same thing in this photo. For example, the top of the modem on the right is actually the hottest point, and the coolest point is actually right down there on that fan cowling, and it's moved them up and to the left. So I don't know what's going on. It's really strange. So I'm not sure if this is a bug or it must be, but I haven't been able to reproduce it. But yeah, this whole series of photographs I took, it did not center the points correctly, which is a big fail on Seek's part. So just a shot of a hand, and I can just basically, if I touched something metal, you can see in the parts of my hand that have lost thermal energy to that object. So it's interesting. You can also do the opposite of this. You can have, for example, a floor or something. You look at it and it's uniform, and you can just have someone walk across it, and you can see footprints of where they've walked, or you can see what surfaces people have touched. It's actually quite neat. Depending on how long they were there, the heat will linger from anywhere from seconds to minutes. You can also look at the thermal performance of your house. This is one of the big things that Seek's marketing this as. So this is just a shot of my front door, and you can see it's fall now, so it's getting a little bit cooler outside. So you can see along the right and bottom edge of my door, there's obviously heat escaping, and so obviously I need to improve the weather stripping there. This is just a shot from my deck outside, looking back towards one wall of my house, and you can see obviously the brick is significantly warmer than the surrounding air surrounding trees and stuff outside, which of course makes sense. And you can see relatively what walls of your house, etc., are losing the most heat, which could be useful to homeowners. Again, another shot. This is just a sliding door. Again, you can see there's more thermal loss there. This is the induction cooker that I did a teardown and review of a while back. I'll link that in down below. You can see I'm just boiling a pot of water on here, and you can see, of course, the water is the hottest here. The pot is actually really the hottest part here. However, due to the emissivity of it, it's not showing as the hottest. And of course, you can see where the heat is leaking through the glass plate on the top of the cooker, and then after removing the pot, you can see what's remaining. And here I just had a fork which I just dipped in the boiling water for a second and put on a counter, and you can see, of course, where it's hot, but I left it there for just a second and then I slid it over, and you can see now that persistence effect where you can see where the hot object was on the counter. So this is just a test video I did. This is with my Samsung Galaxy S4. So this is the probably the lowest frame rate you'd see on a video. This is just boiling some water on an induction cooktop, and it's really interesting to see this. This is actually a lot more interesting than I expected it would be. Of course, invisible, this is just a container with some still water in it, but it's got this really nice effect, and you can see the convection of the water as it gets heated near the bottom of the pot and then rises to the surface. And it's actually quite nice. I don't think I've seen this on a thermal video before. So I'll post this full video as a separate video that you can watch if you want to watch the full thing all the way to a boil. And again, this is another shot, same time, just putting some sauce onto a pot full of pasta and stirring it in. So this has some pretty serious thermal gradient changes. So you can see the kind of performance you'd get if you used a phone like that. So this is pretty much sort of a worst case scenario almost. So hopefully all these clips and this info was helpful. Possibly if you want to purchase this camera or another thermal camera like it. I know there's a bunch of cameras on the market now. Of course, this is the lowest cost one. However, it has some limitations that some of the other products don't have. So anyway, thanks for watching.